For more than a century, physicists have tried to understand whether true nothingness can exist. Every time they got close, they found something instead. You were taught the universe began with something, a spark, an explosion, a beginning. But ask a physicist what came before that beginning, and they won't describe a before. They'll describe a problem, because the deeper we look into what we call empty, the less empty it becomes. There's a number lurking in that emptiness. Physicists gave it a name: zero-point energy. Even at the coldest, darkest, most vacant point the universe allows, the number never reaches zero. Current quantum field theory suggests a perfectly empty vacuum cannot remain perfectly still. And in 1948, two men decided to test it. The experiment seemed impossible. If nothing truly exists between two objects, then nothing should happen. No force, no movement, no interaction. But when two perfectly polished metal plates were placed unimaginably close together, they began to move. Not because something pushed them, but because empty space itself refused to stay empty. The plates drifted toward one another, tiny, silent, measurable. The force was incredibly small, yet it matched the prediction with astonishing precision. The vacuum was doing something, and physics could no longer pretend that nothing meant nothing. The Casimir Effect changed more than a single experiment. It changed the way physicists think about empty space. According to quantum field theory, every point in the universe is filled with invisible quantum fields. Even when every particle is removed, those fields remain, and they never become completely silent. For unimaginably brief moments, tiny fluctuations appear throughout the vacuum. Particles seem to emerge, only to disappear again before they can ever be directly observed. This isn't science fiction. These quantum fluctuations have measurable consequences. They influence atomic behavior. They affect the energy of empty space, and they have been confirmed by experiments with extraordinary precision. The closer physicists looked at nothing, the more they discovered it was alive with activity. If empty space is never truly empty, then one question becomes unavoidable. Could an entire universe emerge from what appears to be nothing? Some physicists believe the answer may be yes, not because something appeared without a cause, but because the vacuum itself contains energy. Under the right conditions, that energy may become unstable. Tiny quantum fluctuations could be stretched across the newborn universe during a period known as cosmic inflation. What began as microscopic uncertainty could eventually become galaxies, stars, planets, and everything we have ever known. The universe may not have emerged from absolute nothingness. It may have emerged from a reality far stranger than our everyday intuition allows. Despite everything we have learned, there is still no evidence that absolute nothingness has ever existed. Every region of space we have observed contains quantum fields. Every vacuum we have measured contains energy. Even the emptiest places between galaxies are not completely empty. Modern physics no longer describes the vacuum as a void. Instead, it describes a restless foundation beneath reality itself. What we once called nothing may actually be one of the most active structures in the universe. The closer science approaches absolute emptiness, the further absolute emptiness seems to retreat. Perhaps nothing was never waiting to be discovered. Perhaps it never existed at all. Science has transformed our understanding of reality. Again and again, the universe has refused to match our intuition. What once seemed empty now appears filled with invisible structure. What once seemed impossible has become measurable. Perhaps the greatest discovery is not that we found something hidden inside nothing. Perhaps it is that our idea of nothing was never complete. The universe still holds questions beyond our imagination, and every answer reveals another mystery waiting beneath it. So the next time you look into the darkness of empty space, remember, you may not be looking at nothing. You may be looking at the foundation of everything.